Today we're going to discuss about some basics of the mathematics that is required for doing business courses. That's my back to basics is the topic of today's discussion, in which we're going to cover different very basic things like order of operations, fractions, decimals, and rounding. Percentages, algebraic expressions, linear equations, and natural logarithms. So these are very basically we touching just the basics of these, and we will discuss in detail in coming chapters regarding these topics. Now, why math is so important for our understanding of other business courses, because business world and the personal life as well is revolving around numbers. We know that when you analyze a business, we have to look at the numbers of profit, revenue, sales. All these are the numbers that gives us an idea whether the business is going to be a successful or to be towards the failure. So that's the way that it is important to not only to understand or read these numbers for the business, but also to know how to calculate and arrive on these numbers. For a personal life, we know that every day we have to deal with a number of prices, discounts, and other variations we have to calculate when we are buying anything or when we are selling something. We are looking how much interest we have to pay if you borrow money, how much returns you are getting on your investment, and all these things, how much income you are earning, how much bills you have to pay. So all these things are numbers, and it's important to understand how to calculate or how to read those numbers. Let's start, and we are going to start with the first topic, and that's an order of operations. So if the mathematical expression is given in a way in which there are many different signs of mathematics, like plus, minus, or addition or subtraction, multiplication, division, and exponents, or sometimes you also see the brackets. So how we do this, it's not our choice that we want to do which one is the easy or which one is a first comes, then we have to solve it. No, there is an order we have to follow, and that's what we call it as an order of operations. So before going into orders of operation, we have to look at some symbols that you have to face when you read some mathematical expression. So first thing is the brackets. Brackets we see here, there can be three different types of brackets in an expression, which can be a round, square, or curly. Then comes the exponent. Exponent means that you have to write in raised power. Like 2 exponent 3 means that you are multiplying 2 3 times, not 2 into 3, but 2 3 times. 2 multiplied by 2 multiplied by 2. So that's what we call it as an exponent. Is always written in a superscript, means a smaller one at the top on the right side of the number. We can also write this exponent in Excel with the symbol of hat. So if we want to write in a cell the exponent like 2 exponent 3, so how do we write it? We type 2 and then shift 6, that will give us a small hat, and then we write the number of exponent, which can be, in our example, it's 3. So this is the way that we can use the symbol hat for in computer as a exponent. Then comes the sign of multiplication, and very standard one from the very childhood. We learn that multiplication is expressed with the cross or with the X. But in computer languages, we use different symbols for multiplication. It can be a static, shift 8, or it can be a dot, or a decimal, or we can also multiply if there is no sign between two numbers and the numbers are separated with the bracket. We also do the operation of multiplication. Now, then comes the division, and division sign is for a very standard mathematics, division sign is dot, horizontal line, and then dot. This is a very standard symbol for division, but divisions are also can be written in a fractional way, like backslash or the line between the two numbers over. The one is a numerator and the other one is a denominator, and that's can also be written as a division. Addition and subtraction, we all know that the symbols. Now, when you are using calculator for your mathematics, you have to be careful that how the calculator is set it, or the setting of the calculator is important. So normal standard, which is 2 decimal places, but you know that in mathematics, sometimes it is important that you have to keep the decimal places as much as possible, or as we are getting. But in financial world, or in terms where we are dealing with the money, we write only up till 2 decimal places, because the cents are out of 100, so that's only 2 decimal places are possible for a dollar amount, for any dollar amount. So 2 decimal places is good if you are doing some math questions in which the dollars are involved. But if you want to extend this decimal places to your in your calculator, so you have to press second. That's a key available in your financial calculator, and then format and how many places you want. You enter that number like 986, and then you enter. Then it's going to be set as a decimal places 9 or 6 or 7, whatever the number you see. Second format, and then you enter the down arrow key. So in this case, what is going to happen? You see the date format, the US format of writing numbers, because in US format we place comma after every 3 or after every 1,000. The objective is that by this way, it is easy to read the numbers, because if it is 9 zeros there, so you cannot, it is very not easy to just look at it and say that it's 8 zeros or 9 zeros. So you have to count every time, which creates a inconvenience. So if we place after every 3 zeros a comma, that makes it very easy to read these numbers of zeros. For example, if you write a million, so you put 3, 3, and then 1, and with separated by comma. So we just look at it and say that it's 1 million. You don't need to count 6 zeros there. Then there are 2 ways that the calculator solve equation, and this is known as a chain method, which means that your calculator will apply resolve equation as you punch it in without regards for the rules of BEDMAS. This is not acceptable and need to be changed. So you have to change it. You have to change it to the chain method. So normal standard setting is chain method, but we have to change it so that they can follow the BEDMAS. What is BEDMAS? We will just discuss. There is a AOS standard in the calculator as well as, and then we have to second quit back to the regular calculator uses. So these are the ways that how you can set your calculator for doing your calculations. BEDMAS is an acronym. It's not a word. It's an acronym, and the acronym stands for brackets, exponents, division, multiplication, addition, and subtraction. So this acronym is going to give us an idea of operations. It's simple to remember. Like they developed this acronym in order to keep it always in mind that what will be the sequence or the order of operation will be. So the first thing you have to solve, if it is in your mathematical expression, if it is the brackets, you have to solve first the bracket, then you have to solve the exponents, then you have to move on. If there is any deviant, then you have to solve for deviant, and then multiplication and addition and subtraction. So this is the order we have to follow whenever we are solving any mathematical expression. So here is an example, like there are three examples are given, and we have to calculate the result of this. So in the first expression, if you look at, and I try to do it here, in the first expression, we see there is a so in the first expression, we see there is a deviant. So according to BEDMAS, we have to do first deviant, and then we have to do multiplication, and then we do subtraction. So if we write it in a way, so the first thing is we divide 30 with 5, we get 6. And then in order, we have to do this one operation, which is 10. And then we have the order to do this addition. So 16 is the answer for our first. Similarly, if you look at the second one, so according to BEDMAS, first we have to solve these brackets. Sorry. First we have to solve for this bracket, and then we have to go for an exponent, and then deviant, and then addition, right? So first of all, what is the sum of this bracket is 9 exponent plus 18 deviant or divided by 2. So it's going to be 81 plus, I'm doing with each and every step so that you can understand. So you see that each step we followed. Now, in the third example, we have two brackets. The first one is this, and then there is a round bracket around the curly brackets. So how we can do this? We have to first solve the brackets. Now within the bracket, we have to also follow the BEDMAS. So based on this, if I'm going to write, so 3 plus, now 22 multiplied by 3 is 66. Now we do the brackets, and now it's going to be 69. And if we solve 69, so you see here, this is the answer. So this is a practice for practicing BEDMAS, how we have to follow the orders. The next comes up fractional, decimals, and rounding. So whenever there is a fraction, we have to look at whether it's a proper fraction or improper fraction. And fractions can be converted into mixed number, or we call them as a complex numbers, or maybe further we can compound numbers or complex numbers. So we further make it complex. And when we try to equate fractions, we can solve the missing numbers as well. So proper, the numerator is smaller than denominator. If the fraction is like this, that the numerator, this one is our numerator, and this one is our denominator, right? So if the numerator is smaller than denominator, then it is a proper fraction. And if is opposite to that, like here the numerator is bigger and denominator is smaller, this is improper fraction. We can further solve it, or we can convert this into a compound number or a mixed number. So this is a mixed number in which we have a whole number plus a fraction. Whole number plus a fraction. And if this fraction is further into a fraction, then it's become more complex, and we can make it more complex and more complex. So it is important to follow BEDMAS in solving these fractions as well. So there is also a possibility that the fractions are equal. And if that is the case, it means that each two or more fractions of any time that have the same numerical value upon completion of the division, note that both these are so that's the case here is assuming all numbers are positive. So we are saying then comes the decimal. As I already mentioned that in financial calculations, we normally write it up to 2 decimal, but the rule for decimal is that if you want to round it, if it is 5 or greater, you round it to the next highest number and eliminate the other the decimals places. But you have to be careful when we are rounding it. So here is a case, like we want to solve this. And if we want to solve this, it means that this x is equal 7 over 12 should be equal to 49 over 12. So if we can solve this in a way like 7 over 12 is equal to 49 over x. So we can cross multiply these and we can get it like 7x is equal to 12 into 49. And when we divide both sides with 7, so we get it 84. So x is 84. We can solve it. It is very standard in mathematics that whenever we want to write an answer in a fractional way, the fraction should be in their lowest possible form. If you look at this fraction, although it's a proper fraction, but it is not in its lowest possible form. How we can change this into lowest possible form? If we divide both the numerator and the denominator both by 5, we get it 1 by 10. So this is the lowest possible term of this fraction, which are equal. So they are equal. Whether you write 5 over 50 or 1 over 10, there's a same equal. But you have to write it in a standard way. We have to write it in a lowest terms. Now, if there is a complex or compound numbers and we want to change it into decimals, how we can do this? So the first one is very simple. If you go 2 by 5, so it means that you are dividing 2 by 5. Now 2 is smaller number, so what we can do is we have to put a decimal to make it 20. And now if you do 4, then it's going to be. So what is the answer? If you want to convert this into decimals, the answer is 0.4. Right? If you want to convert this into fraction, now this case is a slight different. The one method is that you multiply the numerator with the number, whole number, and then add the numerator, denominator multiplied by the whole number into plus the numerator. And then whatever you get is your numerator, and the denominator is as it is, and then you can solve it by dividing. But the other way is that we keep the 6 as it is, plus we solve the other with the decimal places. And if we get it, the decimal places like 0.7 divided by 7 divided by 8 is 0.9. No, 8. 7 divided by 0.87875. And we can write it like 6.875 is the answer for this compound number. And similarly, we can do this with the third one. It's a 12 plus, we can change it into 4.5 divided by 0.2, 1.2, 1.2. So if you solve this 4.5 with 1.2 is going to be 3.75, and the answer is 15.75. Let's check that. 4.5 divided by 1.2. Yeah, 3.75. So that's it. So you try by yourself these numbers, and I hope you will get the answers for these. Now the next topic is our percentages. We use percentages very commonly in order to express the overall situation. Like we represent the inflation rate in percentages, like 7%, 6%, 8%. We represent our grades in courses with the percentages, 80%, 70%, 60%. We also represent the growth in our GDP, growth in our profits, and all these things in terms of percentages, as well as if you want to tell that how the population is increased this year for any country, how we represent it, we just use that, okay, 1% increase, 0.5% increase, 2% increase. So we don't need to remember a large number of values like 2 million, 200 million, or whatever it is. So percentages makes it easy for us to understand the things. In percentages, we have three things. One is called as a base on which we are calculating the percentage. The second is a portion. When we calculate the percentage, we get what number is that is our portion. And the third one is the rate of percentage, right? The rate. These are the three things. Now we all going to learn this three things in a different situations. For example, if your total income is 3,000 per month and you cannot spend more than 30% on housing, what is the maximum amount of your total income that can be spent on housing? So the base here is 3,000 and the rate is 30%. So what you want to calculate, what portion of the income you are going to spend on housing. So it's going to be 900 because 30% of 3,000 is 900. Now the second question is saying your manager tells you that 2014 sales are 102% of 2013 sales. The sale for the 2014 in are 1.487003 million. Whatever the sale, what were the sales of in 2013? So we want to find out the base for 2013. So what we have to do, we divide this number with 102 and we get the numbers that is appropriate. Or if I try to find it out with the help of a calculator, like so it's going to be 487 003 divided by 102. So we get it 1457. This one, and 461 or 4607. So I'm converting it into 1. 1487 003, so 461. Okay. In Calgary, total commercial real estate sales in the first quarter of 2008 were 1.28 trillion. The industrial, commercial, and industrial institutional ICI land sector in Calgary had sales of 409.6 million. What percentage of commercial real estate sales is accounted for by the ICI land sector? So here we want to find out the rate. So what we have to do, we have to divide this 409.6 with, it's a billion. So we have to be careful when we are using it. So we can say it is 1 billion. So we want to convert it into millions. So we multiply 1.8 into 1280 million, right? And that's going to be one. So we divide 409.6 divided by 128.280 into that. So we get it. It's a 32%. We multiply it with 100, so we get it 32%. So this is the way that we calculate the percentages. There is a need to understand the algebraic expressions. Algebraic expressions are following a certain rule, like when we are using A, B, C, or any other variable symbol. We have to follow up very standard rules. And the first rule is saying that if the base are identical, like base here is y, add the exponents if they are multiplying. So we see here that y multiplied by y. So a into b is y is equal to a plus b. So that's what y exponent a plus b. The deviant case is like if the base is same, then again, if the terms are, or these expressions are dividing, so what is happening, that the exponent should be subtracted. The base is unchanged, so retain the unchanged base, and we write it like y exponent a divided by y exponent b. So what we can do is y is equal to exponent a minus b. Now, if there is a multiplication possible, raising powers to exponent, in that case, if a single term is raised to an exponent, each factor must retain its base, and you must multiply the exponent for each by the raised exponent. So that's an exponent multiplied by exponent. And here we see an example like y exponent b, z exponent c raised to power exponent a. So by this way, the end result is that we have a yab into zaca or ac. So we can write it like, or we can write it in a way that if the case is like z is dividing, so in that case is also the same. So 0 exponent, if the exponent value is 0 for any number, any expression, is going to be, the answer is 1. Any base to a 0 exponent will always produce a power of 1. So this is explained later in the algebraic section when we will discuss in detail. Negative exponents, if there is an exponent is negative, we can change the denominator into a numerator and the exponent become positive. And if it is a numerator, we bring it down to denominator and change the negative exponent to positive. There is a possibility of a fractional exponent as well, like y exponent of a over b. So we can write it in this way as well, like b into under root y of exponent a. Now this is the practice. Like we see here that h is a base which is common in both, and these are multiplying. So what we do, we add the exponent, and that's the answer. Here we say that h is a base which are common here, and the exponents are 14 and divided by h exponent 8. So what we do, we subtract and we get it h6. Here we are saying that this the exponent raised to further an exponent. So we multiply each base with their exponent. So h exponent 3, k exponent 15. Why? Because 5 multiplied by 3, 15. M exponent 9 and n exponent 12. Here we see that the exponent is 0, so that means that the value is 0. We apply the rule here, rule 5, like x square y 4 over x minus 2. So we see here the exponent is in negative. So what we can do, if we take this to as a numerator, it's in a denominator, so we can take it to the numerator and make it the exponent positive. And we then apply that these are the same bases. So we apply the rule that their exponents is going to be add up. X here is square, and in the numerator also there's a base of x, but the exponent is 1 positive. So if we take this 1 positive up, then it becomes a negative, because we are changing the denominator as a numerator. So by this way we get the end result is x y exponent 6. If there is a fractional exponent, so we take a fraction and we can calculate the exponent, or we can take the 6 exponent, applying this rule, like take a 5 outside, multiply by 6 exponent, under root exponent 3, so we can apply the rule here. So now the last, one more thing is that linear equation and manipulating and solving, how we deal with the equation. So first of all, if there is an equal sign in between in the mathematical expression, then we define it as an equation. If there is no equal sign, then it is not, like this one is not an equation. The reason that there is no equal sign, this is also not an equation. The reason that this is there is no equal sign here. But if look at this, we see that there is an equal sign, so it means that it is an equation. So the solution of equation is that we want to solve it by doing certain operations, so that we can bring the whatever the element we want to calculate on one side and all others on the other side. But the rule is that whatever you're doing on one side of the equation, you have to do the same operation on the other side of the equation. So for example, in our first case, we see that here we are doing 3x minus 5 is equal to 15. So first of all, we apply to multiply this 3 with these two numbers. So 3x minus 15 is equal to 15. So what we do, we add 15 on the both sides. So we get it 3x minus 15 plus 15 is 15 plus 15. So we did this addition on both sides. Now with this addition, this minus 15 is eliminated, is going to be 3x is equal to 30, and then x is equal to 10. That's the way that we do equations. So this is a single equation with one variable x. In our second question, it's a b, and in the third question, it's m. So these are single equation with single elements. But if there are two equations, and definitely we need two equations if there are two elements in it or two variables in it, like x plus y is equal to 6 and 3x minus 2y is equal to 8. So what we have to do, we want to get the values of x and y. So there are many ways that you can do it, but the easiest way, which in this particular situation, is that you keep the x on one side and write the 6 minus y like this. So because what we are doing, we are subtracting minus y from both sides, and by this way the y of this side is eliminated and is going to be on the other side. So you use this expression, put it here in place of x in the second equation. So there is going to be 6 minus y minus 2y is equal to 8. And when we solve it, is going to be 18 minus 3y minus 2y is equal to 8. And so 18 minus 5y is equal to 8. And when we solve y, we get to be 2. So if y is 2, then x is equal to 6 minus 2 is equal to 4. So x is equal to 4. So this is the way that we solve these equations, and try these remaining by yourself. And I hope you will get the answers. So, but we have to be very, you have to think different options to solve the equations. Sometimes, like in this, in the sixth question, these are fractions. So try to multiply with some number so that you can eliminate these fractions and it becomes a simple number, so you can solve. Maybe there is a possibility that they are in decimals, but you can deal with that. The last thing is a logarithm. Logarithm is defined as an exponent to which a base must be raised to produce a particular power, right? So it's a very definition. The technical definition is exponent to which a base must be raised to produce a particular. So base is raised to particular exponent, that is the logarithm. So logarithms are of two types, like a base value of 10 logarithm and the natural, or the base the value of exponent logarithms. So this is referred to as a common logarithm. Thus, if you have a 10 raised power 2, so 10 raised power 2 for exponent 2 means that it is 100. So the log of 100 is 2. Log of 100 is 2. Because the base is 10, and the base 10, the exponent which makes 100 is the log of that number. So that's what we are getting here, log of 2. Base of exponent, which e, and e has a particular very specific value in our mathematics. It is 2.71828182845. That's an approximate value of e. Now, if we are taking and we also call that as a natural logarithm, natural log. And we use the symbol len. And for this, we are using the symbol log, log, log. And for this natural log, we use the symbol ln. So again, if we are here, want to take a natural log of exponent 3. So this is going to be what is the base? The base is this y. If you take the natural log of this, you get the number as a 3. So natural log also follow a certain rule, and here we are discussing these 4 rules. The first rule is that when we take a natural log of any number, you can get it through a table, or use a calculator or a Excel to calculate this natural log. Now, natural log of a number which are in a fractional mode, natural log of a number which are in a fractional mode, the solution is this, that you take the natural log of a numerator minus natural log of a denominator. So that's a rule that you have to keep it in mind. Natural log of 10,000 over 6,250 means that natural log of 10,000 minus natural log of 6,250. If there's a raised power, like natural log of 1.035 exponent 12, so the rule of logarithms is saying that 12 should be multiplied with the natural log of 1.035, right? So this is the way that we do with the exponent. So this is the way that we can solve these things. So this is just a very basic touching. We go in deep in these mathematical operations more in detail in coming chapters, but here we are just touching the base, and that's why we named this topic as a back to basics. Thank you very much, and if you have any question, write in the comment box, so I will reply you. Thank you. Bye.